My name is Marcin Kovac. I'm the Director of the Research and Development Department here at the IGLOO company. In today's episode, I would like to present to you one of our most important products, the MultiTherma heat pump. MultiTherma is an advanced inverter heat pump. It is specifically a monoblock type heat pump, where the fundamental function of this unit is naturally heating. However, our heat pumps are also capable of cooling, as they operate in a fully reversible mode and can additionally supply us with chilled water for various air conditioning systems. Currently, we offer three sizes of devices, a 12, 17, and 21 kilowatt heat pump. The 12 is a unit that can operate in a range from 1.27 to 12 kilowatts, the 17 from about 2 to 17 kilowatts, and the 21 from 2.4 to 21 kilowatts. These are devices with a very wide modulation range. They are capable of modulating their performance within a range from 10% up to 100%. Therefore, a unit like a 12 kilowatt model can also be appropriately selected for a building whose actual demand isn't necessarily 12 kilowatts, but perhaps 6 or 8 kilowatts. This poses absolutely no obstacle. Such a device can effortlessly operate year-round at a power of even 4 kilowatts or even below 4 kilowatts. So it is a very flexible device that can be adapted to a range of applications, and for all newly built homes whose energy demands are at a low level. It absolutely proves its worth and can be used even though it is nominally a 12 kilowatt device. Due to its inverter-based construction and the employment of a permanent magnet brushless 6-pole electronically commutated compressor, the load and torque characteristic, the load versus torque of such a compressor is such that the device operates more efficiently the lower the revolutions it runs at. So, consequently, this device, even when operating at high RPMs, has very high energy efficiencies. The COP of our heat pumps reaches even 5.5. However, the more modulated the pump, the higher the COP and the unit's energy efficiency. So if we were to simply imagine that we have a small house where a pump like this is operating and it's perfectly sufficient for heating that entire house throughout the whole year, and then next to it we were to build a second identical house, operated in precisely the same manner and connected to it. Instead of just one MultiTherma 12 unit, as in the first instance, we connected two MultiTherma 12 units, which would effectively be like a pump twice as large, a cascade of two pumps. This might sound paradoxical, but the house that will have two devices will actually consume less energy than the one that has only one device. That's because in the first scenario, that single device will be pushed to its absolute limit, whereas in the second case, both of those two devices will be operating at half capacity, and this will result in a much more effective and efficient operation. What is it made of? No? What does our device consist of? Yeah? Of course, this is what it looks like. Now we're looking at the outer casing. Let's take a look inside. Let's see what this device is made of. Inside we can see the electrical panel. Normally we wouldn't see this panel like this after opening the covers, because there's also a sealed lid here, which has now been removed. I don't have it with me at the moment, so we can look inside and see what's in there. So we have the electrical switchboard, the main controller, the LTE communication module, the drive, and accessories for controlling the pump's automation. Each of our pumps comes equipped with an LTE module. This means that as soon as it's plugged into the power supply, it instantly appears in the cloud and we can immediately log into every single one of them. There's no need for any configuration, no Wi-Fi networks, no 5 internet cables. You just need to connect this pump to the electrical power supply, and you can immediately connect to it from your mobile phone or through a web application via a website or even a laptop, and then you can manage or control this pump. Next to the LT module, we have the main controller and a drive that manages the compressor's operation. Inside, there's a Japanese inverter compressor from Mitsubishi. It's a very good design. This compressor is built in such a way that, because it's a high-speed compressor, it can operate in a range from below 900 to 7,200 revolutions. Therefore, throughout this entire area, it must be fully lubricated, both at 900 RPM and at 7,200. And here, an unusual design was used, although applied by the Japanese for years in many constructions. And that's one of the reasons why we chose this version of the compressor, specifically with pressure lubrication. Well, it's constructed in such a way that within this compressor, at a specific height, there's an oil level. Here at the bottom, in the casing, we have oil that lubricates it. And now above this oil, in this specific compressor design, we have high discharge pressures. As a result, the oil is pushed down by these pressures. This top cushion hydraulically forces the oil downwards and into channels that lubricate the entire compressor. This is a much better solution than in most compressors on the market, which have centrifugal lubrication or mechanical pump lubrication, meaning a pump whose output is dependent on the compressor's RPM. In this specific case, the lubrication is independent of the compressor's RPM. It doesn't matter if we operate at 900 RPM or at 7,000 RPM. Lubrication is just as effective because above the oil, there's roughly always a similar consistent pressure. This high pressure equally effectively pushes the oil into the lubrication channels, lubricating the entire compressor. So this represents a highly effective compressor design which performs exceptionally well within heat pump systems, particularly for heat pumps operating in extremely harsh environments, those that frequently need to undergo defrosting cycles and function reliably in very low ambient temperatures throughout winter. The compressor itself is encased in a special acoustic enclosure, which is known as the sound shell. Its primary purpose is to completely eliminate the noise generated by the compressor, but also to retain a significant portion of the heat within the compressor unit itself, so that as little as possible is emitted into the surrounding environment. The compressor is mounted on 4 vibration isolators to the base, which base is again mounted on further vibration isolators to the heat pump base. Consequently, we have a double vibration isolation system installed in this heat pump. The next important component here is the heat exchanger. Right here, underneath this protective cover, you'll find the heat exchanger. This is the condenser, which is where the compressor transfers the heat it generates. This heat is then subsequently transferred to the water that is being heated by the heat pump. We exclusively use condensers from reputable European manufacturers. These are components from Calvion and Alfa Laval. They are 2 highly regarded, excellent European manufacturers of heat exchangers. So these are also high quality components. There is no concern that, as is often the case with cheap Asian devices, you would encounter instances of the heat exchanger dissolving due to glycol. And therefore, in our heat pumps, you can confidently use glycol solutions if you so wish, specifically both ethylene and propylene glycol solutions. We don't impose any restrictions here. We know there are heat pumps on the market where after glycol is poured in, the heat exchanger can even dissolve. That's not the case with us. On the water circuit, here we have the inlet. Down here we have the water inlet from the system, which passes through the heat exchanger, and then the water outlet back to the system. A flow meter is also installed on this water circuit. This is a device that continuously monitors the flow of the heating medium, which is water at this moment, through the heat exchanger. Firstly, so that we have information on what this flow is, allowing the pump to adjust its operating parameters for efficient work and management, controlling the compressor. But also for safety, we need to have this information. Not only whether there's a flow or if there isn't one, but also specifically what its value is in cubic meters per hour. This flow meter provides us with this capability. So we have not only the information that flow is occurring, but also information about what kind of flow it specifically is. And we can also use this value to influence the device's control. Of course, the unit also features a range of other refrigeration automation components, such as a liquid receiver, a liquid refrigerant separator, or, for example, a 4-way valve, which is used to reverse the cycle. So these are some things that are, let's say, standard, let's call them that. However, the liquid separator we use isn't entirely standard because our device uses a liquid separator with a regenerative heat exchanger. This is a specially designed device, a unique construction that not only allows it to catch, as its name suggests, acting as a liquid separator, meaning to extract liquid, but also can be used for heat exchange. We happen to have such a cut-open component here. I can show you how it looks. This is what such a device looks like. So, a standard liquid separator doesn't have this element at all, this coil. In our device, we have this is a separator element. This tube is a separator element. And additionally, it has such a coil. So our separator has not 2, but 4 connection ports. This improves the energy efficiency of the entire process and the entire device. Besides this separator in the pump, we have 2 more places where we can regeneratively exchange heat and thus improve the device's thermodynamics. One of them is the evaporator bottom, the very last tube. The final 2 tubes within the evaporator serve precisely as a subcooling heat exchanger for the liquid refrigerant. And the next component is the drip tray, where heat exchange also takes place. We heat this tray using a liquid refrigerant, which cools the refrigerant while heating the tray. This way we move on to the next component, which is the drip tray located beneath the evaporator. This tray is designed to be heated specifically by the liquid refrigerant and is constructed in such a way that its bottom part is made of acid-resistant stainless steel sheet and the top part is made of ABS. This is an ABS molding. It's visible inside under the fan. It features a funnel for condensate drainage and positioned between the ABS casing and the acid-resistant sheet metal. There is polyurethane foam and a copper coil, which actively heats the drip tray using a liquid refrigerant. This innovative design not only provides cost-free heating for the drip tray, but also ensures exceptional energy efficiency for the entire unit. Of course, the the heat pump casing is sound insulated with a special foam made of two layers, rubber and foam. The rubber absorbs low frequencies, and the foam absorbs high frequencies. Consequently, any noise that is generated within this space is first captured by the sound cell and then by an additional layer of insulation, which effectively restricts its escape to the outside. The entire assembly is enclosed in a sheet metal fabricated from a specific grade of magnetite steel. It's a steel that is resistant to corrosion and possesses self-regenerating properties. So if we were to hypothetically scratch such a heat pump with a nail, for example, the scratch would naturally remain, but no corrosion would form at that spot for even 25 years. Therefore, we provide a 25-year warranty on this heat pump's casing. Our devices are also covered by a 5-year warranty on the entire unit, a 10-year warranty on the compressor, and a 25-year warranty on the unit's casing. That's all from my side. Thank you very much, and I invite you to the next episode.